So, the first section, as you would imagine, is a lot about just introduction, getting you to look at the terminology and the basic concepts of trigonometry. So, again, if you've seen the video lecture for, this section, then you would have seen all of these, basic concepts here. But, we will obviously be doing a lot of discussions about angles. Obviously that's kind of where we begin with our trigonometric topic over here. So some of the things to keep in mind when you're working with these angles, as you can see in the image over here, the side where you begin drawing your angle at is what we call as the initial side. And the idea is you rotate it in the counterclockwise direction, and that ends up leading you to your terminal side. So you start with the initial side, the end point of your ray of, just the half line or the ray that you are using. The end point of that is what we call as the vertex of our ray. And then, of course, like I said, you go in the counterclockwise direction, and where you end up at, that's your terminal side. Now, normally, if you put this on your X and Y coordinate plane, the vertex of your half a line or your ray is going to fall at the origin. So that becomes your vertex. And then your initial side actually falls right on top of the positive x-axis. So this is what we talk about when they say your angle is in the standard form. You put your initial side on the positive x-axis, and then depending on, wherever your terminal side will end up, you always go in the counterclockwise direction. So you will see a lot of times they will ask you to keep your angle in the standard form. So that's what you do, is keep the initial side on the positive x-axis. The vertex of that initial side will fall on top of the origin. And then, of course, wherever your terminal side ends up. Now, depending on, where that terminal side is going to be, your angle can fall in the first quadrant, because remember, these can be broken down into quadrants. So this quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Again, we label them counterclockwise also. So you can have, when you keep your angles in that standard position, you actually have positive values on your angle when you go in the counterclockwise direction, but your angles will become negative if you go in the clockwise direction. So keep that in mind again as we're working through positive angles in the counterclockwise rotation, and then with the clockwise, you get negative angles. Normally we use, as you can see, Greek letters to signify these angles. So alpha, beta, theta, of course, is one of the most common letters we use when we're talking about these angles. So Greek letters, and then we use capital letters A, B, and C also sometimes for these angle measurements. So, again, just some terminology to kind of keep track of. Now, you can see again in these images over here, when you're going in the counterclockwise direction, you have a positive angle. If you go in the clockwise direction, you will have negative angles. We use the terminology of co-terminal angles because the idea is, they are sharing the same initial side and the terminal sides, but, of course, you're going in different directions. So you can see here in the middle graph over here, angle alpha is showing you a positive angle because that's going in the counterclockwise direction. But if we go in the clockwise direction, angle beta here is going to be a negative angle. But together, they are your coterminal angle. So you can see, one definition over here. Now on the right-hand side image, you will again see angle alpha and beta, but they're both going in counterclockwise direction. So you have angle alpha, going from initial to terminal side. So that's one of the angles. And if you actually make a full 360-degree rotation, but you keep going in that counterclockwise direction, you can actually get a coterminal angle from doing that also. So you can either go in the opposite direction and get an angle beta, which will be a negative value, or you can make a full complete rotation and still come up with a coterminal angle. So just two different ways of how you can define those. And we'll do some examples on that here just in a minute. Another thing is the measurement of the angles. Now, of course, we're familiar with using degrees for our angle, but, a lot of times in trig, we actually use the radian measurement also. So again, as you can see here with this image, if we were talking about going from the initial side to the terminal side, that angle measurement, we are showing it by using theta. And the R, of course, is talking about the length of those initial side or terminal side. But you can see when we define that as a circle, basically you're talking about that same value R, acting as the radius of your circle, which will be the length of your initial side and terminal side. So again, remember, this is always in terms of the central angle. So that includes the vertex, the initial side, and the terminal side, and that's the angle we are talking about. So just as a definition for a radian, we are saying 1 radian is the measure of a central angle theta that intercepts an arc, which is, S, as the length, which is equal in length to the radius of the circle. And they're actually showing you that right over here. So we're talking about this arc over here, and we're saying this length for the arc, which is, the letter S, is going to be the same length as what the radius of your initial side or terminal side is going to be. And so we can define this angle in radians as theta equals S divided by R. So again, when we're talking in terms of these angle measurements, keep in mind, the circumference for a circle is 2 pi r. That's going to be that outer edge. You can kind of think of that as the perimeter of your circle. So they're saying it follows that a central angle of 1 full revolution, when you go in the counterclockwise direction, would then of course end up being that whole arc length for your circle will end up becoming that circumference of 2 pi r. Pi is approximately 3.14, so 2 times pi will come out to be approximately 6.28. And then, we're talking about you can have almost 6 radius lengths to make a full circle. Obviously you have a little bit of that gap that you can see over here. So basically they are saying, if you talk about finding these angle measurements, your full circle, that full rotation that you go through, you can actually define that angle as 2 pi. So, we talk about 360 degrees in terms of degrees. So in radians, a full circle is going to have an angle measurement of 2 pi. So we always kind of use that as our standard, kind of like a benchmark when we're talking about these angles. So then they actually talk about, okay, what happens if you just go with half a revolution? So, half a revolution would be, for the full circle, you're only going halfway. So that's going to be 2 pi for the entire circle divided by 2. So you only get pi radians, and that's going to be this half a revolution over here. If you do a quarter revolution on your circle, so that's again going to be 2 pi divided by 4. So when you simplify that, it comes out to be pi halves, and you can see that's going to be this guy over here with just a quarter revolution, of course, starting from your initial side. If you did 1/6 of a revolution, you get 2 pi divided by 6. So as a simplified answer, that's going to be pi over 3 radians, which is going to be this guy over here. So this is actually the measurement kind of idea that we use in a unit circle, which is what I was asking you guys to download. So you start, this is going to be our vertex right at the center. This is our initial side. So, if your terminal side and initial side just happen to be right in this position, that means you're looking at 0 radians, or you can think of that as 0 degrees if you're using degree measurement. Then if you do, from the initial side, you do just 1/6 of a revolution, that will bring you over here. So that would be a radian measurement of pi over 6, which corresponds to 30 degrees. And so you can keep going, and you can see, depending on what your revolution is going to be, at different places, you're going to have different measurements. And this is kind of what we need to remember is, what these different measurements are going to be in terms of, radians, and in terms of degrees. And then, once we get into talking about our sine, cosine functions, we'll talk about these ordered pairs at that point. But right now, we need to know that our full entire circle has a degree measurement of 360 or a radian measurement of 2 pi. So 0, 2 pi, and then, all multiples of 2 pi. So 4 pi, 6 pi, all of them are going to correspond with this starting point right over here. If you do half a revolution, you're looking at pi. So then this one here, if you keep continue to doing those revolutions, all the odd number ones are going to be here. So pi, 3 pi, 5 pi, all of them are going to fall at this point over here, because you can keep going in circles as many times as you like. And again, depending on what kind of example we're looking at, what we're doing, that would be a possibility. So keep this unit circle handy, keep it with you when you're working on homeworks, quizzes, exams, because this tool will really make your life a lot easier. So just a general definition of how these angles in radians are calculated. Now, depending on, keep in mind, again, this is your vertex, this is your initial side. So depending on where your terminal side is going to end up, like I was telling you before, you will fall into one of these quadrants. So all the angle measurements for quadrant 1 are going to go from angle 0, which is right over here, to pi over 2. Of course, not including the endpoints, because you have to be right on the initial side to be at a 0 radian. You have to be right at the 90-degree angle to be at pi halves. So as long as you're not including the endpoints, anything between 0 and pi halves will fall into quadrant 1. Then as you go from pi halves to pi, anything in between is going to fall into quadrant 2. Going from pi to 3 pi halves, of course, now you're looking at quadrant 3. And then from 3 pi halves to 2 pi, because now you have come a full circle. So this guy will now be 2 pi over here. Anything in between is going to fall into quadrant 4. Everything that falls into quadrant 1 is what we call as acute angles, because, if you remember your definition from geometry, if an angle is less than 90 degrees, they're called acute angles. If an angle is more than 90 degrees, it's going to be obtuse angle. So that's, of course, going to be quadrant 2. So again, just some terminology to kind of keep track of. And you can kind of see some other, comments that they're making here about coterminal angles, depending on which direction of the revolution you go into. So again, if you've seen the video lecture for this, then you should have seen, these discussions in that. So we're going to try and use some of those techniques to help us come up with answers over here. So let's start by finding coterminal angle. So remember what I said, you can go into a full revolution to create a coterminal, or you can go in the clockwise direction to basically get a negative value for a coterminal angle. So I've actually got some examples from your textbook over here. I didn't need to click on that guy. Of course, the textbook for you is going to be in a different location than where on the instructor side is, but you should see that under my ebooks, I think is what they call it. So I'm just going to click on our textbook link over here and go under section 1.1. And of course, you've got examples in your video lecture also that you can look at, but I just wanted to pick a little bit of a different example than what you've seen in the lecture. So we're looking at example 15 over here. So they're asking us to determine two coterminal angles. They want one of them to be positive and one of them to be a negative angle. So how about we look at 15b? over here, you've got negative 5 pi over 6. So if you think about it, that's a negative angle. So that already means that you are looking at, let me see if I can clear some of this out. So what's happening in this case is then, obviously you are starting at the initial side, which is still going to be here, but now you're actually going in the clockwise direction. So in this case, what's going to happen is if you're going in the clockwise direction, then your negative 5 pi over 6 is actually going to be coming from here, and it's going to be this one right over here, this angle, starting from the initial side, going to this side over here. Because instead of going in the positive direction, you are going in the negative direction. So think about this. If this is our starting point at the initial side, trying to get rid of some of this extra stuff here. So coming from the initial side to the terminal side over here, this guy is forming our negative 5 pi over 6. So what do you think its coterminal angle will end up looking like? So if this is your original angle, what would your coterminal angle end up looking like?
Doesn't everything wrap around the other way?
Sorry, Hero. They share the same initial and the terminal side, right? But you're just going in different directions. So go ahead, Hero.
Oh, I was just gonna say it wraps around the other way, right? Pretty much.
So just going
clockwise.
Clockwise direction. Very nice. So one of those coterminal angles can be this one over here, where you start again on the initial side, but go in the counterclockwise direction. So remember, if you're going in the counterclockwise direction, then that angle will be the 7 pi over 6, because that's coming in the positive side. So for this guy, we can say the positive angle will be 7 pi over 6. And then they want one negative angle. And of course, we're looking at 15b over here. So what would your suggestion be? And I'll go back to our circle here in a minute. But for the negative angle, what can we choose as our coterminal angle over here? Because you have to go in the clockwise direction to get a negative angle. So what angle can we use to get a negative coterminal angle? Remember how we had talked about making a full rotation? Kind of like what they're doing over here, where you make a full rotation. You can actually do that. And let me pick a different color to show you. So of course, we're starting on the initial side over here. So, we start on the initial side. When we come here, we're of course going to the negative 5 pi over 6. But if we continue and make a full complete rotation, you would actually get a negative angle in that case. So what you can actually do, coming back over here, if we make that full rotation, what you would do is take your original angle of negative 5 pi over 6, and you would actually subtract 2 pi from it, because of course we're going in the clockwise direction, so that's a negative angle, and you would add those numbers together, and that would actually give you what that full complete rotation going in the clockwise direction is going to be. So of course you're working with fractions here, so we would need to give this guy a denominator of 1 and then find your common denominator. So can you tell me what our angle would come out to be when you subtract these two numbers together? Abdulaziz, negative 17 pi over 6. Okay, so let's take a look at that. So, of course, since your denominator is 6 and 1, we can multiply this second fraction over here by 6. So that would end up giving us, the first one will stay the same. So negative 5 pi over 6 stays the same. And then this guy will end up becoming 6 times 2 is 12. So 12 pi over 6. Now that you have a common denominator, you just add the numbers on the numerator. So negative 5 and minus 12 will become negative 17 pi. Yeah, James, very nice. So basically we went in the counterclockwise direction to find the positive angle, 7 pi over 6. But then for the negative angle, you basically subtracted a whole circle. So you went one full revolution and you subtracted from the original angle that you had. And that's how we came up with the negative coterminal angle for, this given example over here. And of course, you can do the same thing with that first example, 5a, pi over 6. So if you try to do pi over 6, let's clear this out so we're not looking at such a big mess over here. So, with pi over 6, okay, so again, this would be our initial side, and you can see pi over 6 is going to be this angle over here. So, to find its coterminal angle, you can actually just look at this guy over here. So that technically to calculate that, you would then take your entire circle, which is 2 pi, and just subtract pi over 6 from it. And you would get, the measurement of this angle over here, which will also come out to be a positive answer. And then to get your negative coterminal angle, of course, you would have to go in the opposite direction. So then you can actually come and do a a clockwise direction to find that. So you will see examples like this in your homework also to find, coterminal angles. Now, I have not included examples with degrees in them, for our examples in class, because working with degrees is a lot easier because it's a matter of, adding, subtracting numbers from 360. Radians is something that you probably have not seen a whole lot before. So radians are the ones, I want to concentrate on. So anyway, that's your coterminal angle. So just remember they share the same initial and the terminal side. Now, some other things that, we will need to discuss in terms of just getting used to terminology is complementary and supplementary angles. So basically, as you can see, when we're talking about two positive angles being complementary angles of each other, that means their total, their sum, has to be pi halves, which basically again means the two angles should add up to 90 degrees. So those would be your complementary angles. And supplementary would be that their sum has to be pi, and pi of course stands for 180 degrees. So you can see in those terms, complementary is 90 degrees as a sum, supplementary is 180 degrees, or basically pi in terms of radians. So again, just as an example, what did I have? 17b. Let's take a look at this guy over here. Okay, so again, complementary, their sum is pi halves. Supplementary, their sum has to be pi. So if one angle is 11 pi over 12, what do you think we would need to do to find the complement for that angle, what would you do?
You basically have the equation like x plus y equals pi over 2, right? And then you
Yeah, because we know the two have to add up to pi halves, right, for the complement.
Mhm.
I would not convert it to, okay, I thought you said something else. Abdulaziz, when you're saying convert to angle, they are already angles, right? Because these are angle measurements. Are you talking about degree? So you're talking about changing the measurement unit? Okay. So yeah, what Hero said. So we know for a complementary, our two angles have to add up to, pi over 2. So if one of the angles is 11 pi over 12, the idea is you're finding what the second angle is going to be. So what do you think this will come out to be? Or is it even possible to do this calculation?
Isn't B too high? Because that's almost supplementary.
Yeah, because let's go back to our graph over here. Um, because actually they don't have the denominator of 12 here. So let's talk about that. If you're looking at 11 pi over 12, okay, 11 pi over 12 is very, very close to 12 pi over 12. Now 12 pi over 12, the 12 can cancel each other out, giving you pi. And remember, pi, like John, you mentioned, is almost right there at the 180 degree or, the supplement level. So since actually this angle is, this angle is larger than pi halves, you will actually not have a complementary angle because you're already beyond that 90 degree mark. So, obviously the two angles added together are not going to give you a complement. So for this one, we would actually have to say, I think your web assign is actually using the terminology of impossible. So it's not possible to find a complementary. So for this one, we would say complement is not possible. Or like I said, I think WebAssign is using the terminology impossible. So can't find that guy. Now let's talk about supplement. What do you think the supplement for this angle will come out to be?
Um, you could add up. You could add 11 pi over 12 plus pi over 12.
Yeah, very nice. Exactly. So that will then end up giving us for the supplement, you are taking 11 pi over 12, adding some angle to it so that our total comes out to be pi. And as I was showing you here, you are just shy of coming out to be pi over 12. So that would be just 1 pi over 12, or you can say pi over 12. So in this case, what you can do is take that pi and subtract 11 pi over 12 from it, and that would end up giving you the answer of pi over 12. So that's going to be our supplementary angle for this example. So you can kind of see that answer said there is no complement, but your supplement is going to be pi over 12. So you want to think about in terms of, how you would do this if these angle measurements were in degrees, but instead of degrees, you want to use the radian measurements. So again, just basic examples, and this would be something you would have done in your geometry classes. I don't know how many of you had to take geometry in high school. I know some schools ask you to do it, some don't. But again, if you've not done this, you can see these calculations are not very difficult. So just kind of keep that in mind. For complement, the sum should be pi halves or 90 degrees. For supplements, the sum should be 180 degrees or, of course, pi. Now we're actually getting into conversions over here. So you can again see that little graph with the degrees instead of radians in there, but that's why I kind of like using unit circles, because normally they will put both of those measurements together in your unit circle. But here's the conversion that you basically want to work with. So if you are going from degrees to radians or radians to degrees, it's a factor of 180 over pi or pi over 180, depending on which format you are going for. So if your measurements are actually given to you in degrees and you're converting them to radians, then that's when you are multiplying your degree measurement by pi divided by 180 degrees. If you are given the angle measurement in radians and you are going to degree, that's when you actually flip that fraction. So you do 180 over pi. So the easiest way to remember is, and let me show you that here. If you're converting degrees to radians, if degree is on the top over here, then degree has to be on the bottom over here. So again, if you're converting it from degree to radian, degree is going to, because you can see the degree is on the top over here, so degree has to be on the bottom so that your degree measurements will, cancel each other out. If you are going from radians to degrees, then you want the radian to cancel out. So since you would have radian on the top here, we would need to put the radian so that pi would go on the denominator. So your radians would cancel out, leaving you behind, with the degree measurement. So whichever unit you are getting rid of, that needs to go on the denominator when you write this fraction 180 over pi or pi over 180. So let's do just a couple conversion examples over here. Let's see, what did I have? 19b. Oh, this was actually another type of example for the complement and supplement of an angle that I wanted to show you. Look at these numbers in 19 and 20 as our examples over here. You will see how they have the number 1, the number 2, 3, and 1.5. Just because it's given to you in that numerical format, guys, and you're not seeing any pi in there, do not assume that this is degree measurement, because it's not. This is actually still radians. They're just messing with you by giving you, instead of, pi over 4 or pi over 6 or 3 pi over 2, they're giving it to you as these constant numbers, 1, 2, 3, 1.5. Because if they were going to use degree measurements, you see how they actually put that little degree symbol next to the number. So that's how you know this is a degree. And when they're giving it to you just numbers with no degree symbol, this is actually still radians. So just be very, very careful about, these kind of examples like 19 and 20 you have in there. All right, so let's take a look at 35b. All right, so converting this from degree to radian. So again, remember that conversion factor is either pi over 180 degrees, or it's going to be 180 degrees over pi for these degree to radian conversions. So since we're doing 120 degrees, let's say over here, so since this is degree on the top, you would need to put degree on the bottom so that you're actually using pi over 180 as your conversion factor. So all you would have to do is reduce that 120 and 180. The pi will stay as it is. You don't have to multiply. You don't have to do approximations for pi. You leave the pi as it is. So basically you are just reducing 120 over 180. So what will that fraction reduce down to? And you want to leave it as fractions, okay? Don't convert them into decimals. So Abdul Aziz, you've got 2 pi over 3. Yeah, because, guys, again, this is something you can help simplify, without a calculator. So that 0 and 0 cancel each other out. So it's the same as dividing by 10. Then you're left with 12 and 18. So you can see both 12 and 18 will go into 6. 12 goes into 6 two times. 18 goes into 6 three times. And you end up getting the answer 2/3 pi. And this is going to be in radians. And of course, you can do the same thing for negative 20 degrees over here. So same thing, negative 20 degrees. Since we have degree on the top, you would put degree on the bottom, and then so pi over 180. Of course, that negative sign will stay. So you've got negative 20 over 180. And again, pi will stay as it is, and you will end up with negative, whatever 20 over 180 will reduce down to. So same thing, get rid of those zeros. 2 goes into 18 9 times. So once and 9, and you're good to go. So this guy will end up being negative, well, I've already got the negative in there. So negative pi over 9. So nothing, like I said, these are really simple calculations. All you have to do is just make sure how you set up the problem. So since this is going from degree to radian, your degree in the conversion has to go on the bottom. Let's take a look at another example where we're converting it from radians to degrees. So again, you can get just a little bit of practice with that. And let's see, which one did I have? 37b. So yeah, let's take a look at this guy here. So now we are going from radian to degree. You've got, let's see, we'll do part B here. So negative 7 pi over 6. So since this is radian, you actually want to put the pi in the bottom and 180 degrees on the top. So what's going to happen in this case, you will see how that pi will actually end up canceling each other out. Because, if you don't put that 180 over pi in the correct format, then that pi does not cancel out. So anytime you are working with radians, converting it into degree, that pi needs to go on the bottom so they cancel each other out. And then, just simplify. So now you will have negative 7 over 6 multiplied by 180. And again, 6 goes into 18 three times. So 6 goes into itself once. 6 goes into 18 three times, and then you can leave that 0 on there. And then just multiply negative 7 times 30, which will give us what? So what will your degree measurement come out to be in this case?
Negative 210.
Yeah, very nice. 7 times 3 is 21. So that's 21. Put that 0. And then don't forget your negative sign, and you are good to go. So, obviously, if you did that with the 3 pi over 2, same thing. 3 pi over 2. And then since we want to get rid of that pi, we put pi in the bottom, 180 degrees on the top. So again, the pi cancels out. You are left with 3 halves multiplied into 180. So again, 2 goes into 18 9 times, so that becomes 90. And then you are multiplying 3 times 90 to get your degree measurement. And again, 3 times 9 is 27. So this guy will become 270 degrees. And again, you can verify those. These are odd number problems. They show you the answer sets to those. So questions on this one, guys?
So when it asks you to find the coterminal or the complement or supplement of a degree, you want to convert it to radians, right?
Yeah, I mean, you will have both sets of examples in your homework actually. So you will see questions for coterminal where they're using radians. So if the original angle is in radian, your answer will also be in radian. If your original angle is in degree, then your answer will be in degree. And same thing with the complementary and supplementary.
Okay,
Yeah.
I guess I'll just have to figure out how to do the degrees and then find the complement and supplement of that, because I think that's where I'm struggling.
It shouldn't be too bad because if you, let me clear this out. So if you look at something like this here, they're asking you to find the complement and the supplement, right? So if you look at number 31A over here, now if you're trying to find the complement, remember the total has to be 90 degrees when you're working with this. So you're basically thinking, okay, 18 plus what will add up to 90 degrees. That will give you the complement angle. For the supplement, it's 18 plus what will add up to 180. So what will those two angles be?
Okay, that makes sense.
Yeah.
Okay.
So, you know, basically what you're doing for the complement is you would do 90 minus 18, right? Which would end up giving us 72 as the answer over here. And we should be able to verify that. And then let's see what would be 180 minus 18. 162, and that would be the supplement and the complement, and we should, yeah, 72 and 162.
Okay,
So
that makes it easier.
yeah, so that's the reason why I did not include examples with the degrees, because you know we think better with numbers, but when it comes down to radians, you know, when we look at pi, sometimes we're like, okay, I'm not sure what to do. So that's why I had included the examples with the radians, but not the degrees. But your math will stay the same. Anybody else? Did you have any other question on the examples we've looked at so far? So again, guys, remember you do need to watch those video lectures because I'm not doing, you know, the theory behind these because that's what I want you to do on your own. And we want to work on examples, you know, of course, when we're in class. So again, just some basic examples on how to find coterminal angles, how to find your complementary and supplementary angles. And now we've looked at conversions going from the degree measurement to the radian and from radian to degree measurement. And you know, actually, a lot of times we break down our degree answers further into fractional parts. So you can actually take a degree angle because you know we're not always going to have nice, clean answers, especially in real life. You know, you're not going to get just 20-degree angle. It may be 20 point, you know, something left over. So usually what happens is when you have your degree measurements in fractional parts, we can actually break them down into minutes and seconds. And so when we're talking about minute, we actually put this prime as the notation for it. So it kind of looks like, you know, an apostrophe symbol, but you use a single prime when we're talking about minutes, and we use a double prime when we're talking about seconds. So you can see over here, we're talking about, you know, if you have 64 degrees, 32 minutes, and 47 seconds, we can actually write that measurement as, you know, with the notation 64 degree, then 32 with the single prime for the minutes, and 47 with the double prime for the seconds. And the conversion here is your 1 minute is going to be the equivalent of 1 over 60 of 1 degree, because you know you're kind of taking the idea of a circle, an entire circle, and you know just imagine overlapping a clock on it, right? And that's where this idea of using minutes and seconds is coming from, because then we can use those smaller markings that you normally have on a clock, you know, for your seconds and minutes to kind of help us out with those fractional calculations with the degree measurement. So of course we know there are 60 minutes to an hour. So that's why we are taking 1 degree and multiplying it by 1 over 60. And then we know each minute has 60 seconds. So basically your 1 hour will have 3,600 seconds. So that's why, again, for the conversion with the seconds, you know, we are using 1 degree multiplied by 1 over 3,600. So that's kind of where these conversions are coming from. So as long as you can remember the conversions from your regular hours to minutes to seconds, then you can, you know, remember those for these degrees, minutes, and seconds calculation also. So let's see. I'm not sure if we're going to have too much time, but I would like to just introduce this calculation to you. What number did I have selected for that? 43. Oh, this is actually converting it from radian to degree using a calculator. Okay, 48 is what I had over here. Okay, so you can see how we are given 135 degrees, 10 minutes, and 36 seconds, and they're actually asking us to convert this into a decimal degree format, which means they just want us to put it as 135 point, some decimal. So we would have to do our conversions over here. So let's take a look at this guy. Now, the good thing is that 135 degrees is going to stay the same. So that 135 degrees is actually not going to change. So that part will stay the same, but then we will have to take these 10 minutes and 36 seconds and convert them into, decimal format. So for the 10 minutes, we are actually going to have to take that. And since we are converting this into, hold on a second. Since we're converting this into, from minutes to degrees, you would have to use this conversion of 1/60 being multiplied into 1 degree, or basically, I actually prefer to rewrite these guys as, you can rewrite this as basically 1 degree over 60, and you can rewrite for the seconds 1 degree over 3600. So we can use that conversion over here, and you would take 10 minutes multiplied by 1 degree over 60, plus we had what, 36 seconds, and multiplied by 1 degree over 3600. And that's how we're going to do this conversion. That 135, like I was telling you, will stay the same. So keep that guy as it is. What do you think our 10 multiplied by 1/60 will come out to be? And same thing, 36
1/6.
multiplied by 1/3600. Go ahead. So, of course, this guy, if you're multiplying 10 times 1/60, honestly, you can just write it as 10/60, and that will be in degrees. And same thing with the seconds over here, 36 multiplied by 1/3600 can become 36/3600, and that will be in degrees also. So Abdul Aziz, you had 10.17. What did you get that for? Because because 10 divided by 60 is going to give you a repeating decimal of 0.1666, repeating. And then the 36 divided by 3600, of course, 36 will cancel out. So technically you get 1/100, or as a decimal, 0.01. So once you have converted those minutes and seconds into degrees, then you just add everything together. So when you take all of these numbers and add them together, and let me see if they told us what kind of rounding they want us to do. Not really. So you know what, we'll just round it to approximately 2 or 3 decimal places for now. But in WebAssign, you can kind of see what rounding instructions they give you, because WebAssign will have its own rounding instructions. So again, you will see that 135 degrees always stays the same. And then just adding our 2 decimal answers from the minutes and seconds will add up to 176. And then, of course, that 6 is repeating. So you can round it. Let's do 3 decimal places for now. 177, and this is going to be in degrees. So I think it really helps just to kind of think about, your conversions over here, instead of 1 over 60 multiplied by 1 degree, or 1 over 3600 multiplied by 1 degree, you can just think of it as these fractions, 1 over 60 and 1 over 3600 when you're doing these conversions. So it's really not that complicated, but obviously, if this is something you have not used before, then you just want to make sure you practice with it. Now, if you look at this, we don't have time for it today, but you can see this one here is actually giving you in the decimal format, and they're asking you to convert it into degrees, minutes, and seconds. So, we will be going in the other direction. So we can pick this up next time. Like I said, obviously our class is a shorter one here. So we'll pick that up next time. But just keep in mind, guys, Monday is Martin Luther King Jr. holiday. So we're actually not going to have class on Monday. So I will actually see you a week from today on next Wednesday. So we'll pick up with the second half of section 1.1, and then we'll also work on section 1.2. So since we won't have a quiz or anything for next class, we should be able to take the entire class and work on these two sections. So your section 1.1 homework is open. Quiz for section 1.1 is also open, and I've actually opened, if I remember correctly, homework for 1.2 also. So please start working on that homework for section 1.1. You have any questions, let me know. And then I will see you a week from today on Wednesday, guys. So have a wonderful weekend.
When is that homework due?
February 1st.
Okay.
Yeah. All right, guys. So be careful. Have a wonderful weekend. And I will see you on Wednesday. Bye, everyone.
Thank you.